an exciting session it was. I can understand there's a lot of questions out there, and I'd like to ask a question to you all. That is there anyone who has got no generation loss of their solar assets? And don't raise your hand. I totally appreciate it. You can't raise your hand because there's a lot of challenges you might be facing if you raise your hand. And this is the market problem, that we are saying what is the real problem, that why system is underperforming. And that is the reason why asset values are degrading. We are a technical advisor and engineering solution provider for solar and energy storage projects with over 15 gigawatt of different asset services that we have provided in 16 countries. And our core strength really comes from core techno-commercial backgrounds. Myself, I sit in IEC or British Standard Committee, writing those standards. They are coming into market for people to use as a code of practice or best practice. A solution, a innovative solution that we'll be discussing, PV-APM, PV Asset Performance Management. It has deployed in various markets, and one of the portfolios that we have worked in the Indian market of 300 megawatt project, that has resulted of additionally generating revenue of 20 million pound. That's in terms of Indian rupees, that would be about, I guess, 200 crores, and additional carbon offset of 33,000 tons. We work with a number of international players into different markets, strongly supported by UK government into different international markets. So there are two main areas of activity that we do when it comes to project life cycle. We manage investment risk, whether for operational assets or for new build development. Technology-wise, mainly solar. Any form of solar, whether from utility scale to commercial industrial sector, and energy storage, whether energy storage integrated with solar or wind, or just standalone energy storage. Service-wise, across the whole project life cycle, starting with value engineering or design optimization. When you talk about design optimization, it's not just technical optimization of a design, it's more of a commercial optimized design. And then technical due diligence, owner's engineering or lender's engineering. And then towards the end of the project life cycle is asset optimization. Now, optimization is a simple word. It comes with different characters, different stages of the project life cycle. Technical due diligence across the whole, again, project life cycle from very conceptual stage to operational stage. Now, in my point of view, what I've seen in many markets, this is an abundant baby, technical due diligence. Why we need this technical due diligence? I do face this question, and my answer would be, wait for a couple of years, see how this plant is performing, and when you see the degradation is happening, that's where your answer is. I really love to talk to anyone who has got an answer that, yes, I have no generation of your power plant. But before we go, I think we should celebrate that we are sitting over a terawatt of solar installation globally, and by end of this financial year, we expect to see over 2 gigawatt of global solar deployment. And this is an achievement itself. And Solar Power Europe, they are forecasting that by 2028, we are expecting to see 1 terawatt per year deployment, which is not very difficult to achieve. And just to see the market trend, this is relatively old projections, but still valid. Scenario of solar deployment has happened in the past, and scenario of future deployment that is going to come, and the level of investment. You can see how the trajectory is changing from Western world to Eastern world, and purely this is because of what is happening, development, etc., in Asian market. Now, this is where the problems start. Over $2.5 billion power loss has happened so far. And if you see, 2019 to 2022 is increasing, nearly doubled up. And again, the estimated value by 2025 is again doubling up. Now, if you see the project sizes, even a 1% degradation of a system in a bigger plant, revenue loss that is coming to your financial model is damaging. It's damaging the whole ecosystem, because we have seen, or we have heard in various platforms that what is the target, different market we're trying to achieve, and there is a significant investment needed. If investor world do not feel comfortable that how operational assets they are performing, how they are operating as they predicted, then there is a risk. It put a risk of circular economy, because when more investment happen by seeing the increase in performance from theory, that's where their confidence goes up and they invest more. PV APM, this is our proprietary technology, PV Asset Performance Management. We have worked in last 3 years in 6 countries, and we see very similar trend. Existing solar asset owner, they are losing revenue because even though they talk about that they are doing a lot of data-driven decision-making process, but not to the granular level that they needed to do. And type of O&M still very much reactive in nature. When something happens, we react. What you need really a proactive O&M. And by not doing so, is loss of generation is happening in those plants, and in simple term, asset devaluation is happening. I'll give you one example. One of the largest developer in the country, when I came to India last March and met them, and they said, we have everything in-house. Last month, they saw a media news that their asset value devaluated 1/3 of what they were expecting. 3 main reasons. Underperformance in wind asset, underperformance in solar asset, and overestimation of their asset valuation when they're trying to exit that particular portfolio. So yes, we do all, but how granular? Question we need to ask ourselves. I think the barrier is there in our mind first. This is some of our case studies. That is to the left table. This is the portfolio I was referring earlier, 300, just under 300 megawatt of portfolio. When you've gone through that exercise, we have seen on average 10% uplift on that portfolio. And some examples from Europe with 8% uplift. Now, if you see the difference between 10 and 8% not very dissimilar numbers in terms of their uplift. Look at the age of those plants, less than 2 years old. They're new babies still. You do not expect that level of underperformance is happening. That means what you're doing, you're adding more DC power to generate the target that you wanted to achieve. This is fundamentally wrong. You're adding operational capex to your system to present your stakeholder or someone that your generation is up to the level that you're expecting. That's just fundamentally wrong. Asset performance management, what it is. It's not just a software, it's not just a tool. It's a strategy. It's a systematic approach that we take where we combine, in today's language, AI, machine learning algorithms. But the important part of it is driven by human intelligence. So it's a combination of high touch and high tech element. High touch is this domain expertise. I go back long, nearly 20 years, when I was involved with MNRE, defining those policy framework of Jawaharlal Nehru Solar Mission. Obviously, we have moved so far from then. And when it comes to high-tech element, that's where these algorithms are. And these algorithms are developed when I used to be in academia. I have a conflict character, academia to industry, but also have another conflict character. I started my power sector journey with coal, one of the CSIR laboratory scientists, researching coal and their calorific value, etc. So it's a combination of these two, seeing a holistic approach to optimize generation of your assets. So it improves overall system efficiency. How do you do it? By collecting data and then going through these different algorithms. They have been analyzed and developed going through different peer review academic journal when I was in academia, and then gone through a lot of real ground tests in the market. So we have so far done just under 1 gigawatt of this exercise, and going very granular, depending on the level of granularity SCADA offer, but also going outside. If the SCADA is not granular, going outside and collecting data from site and feed those information into model. And the outcome of that process is gives a decision-making opportunity for you to take technical and commercial decision going forward. So 3 different stages that we go through. Diagnostic stage, that's where we compare the performance gap. Predictive stage, where we see where the problem is lying, and when a component or a system will fail going forward by seeing the trend in the past data. And then prescriptive model, nothing but a corrective action of individual specific problem. And there's a lot of information that we would need at this stage. So initial stage, we need a lot of as-built system configuration data. And then we go at site, do a lot of IV curve tests, a lot of thermal inspection tests. And then at the end, when it comes to prescriptive model, we just create simple flowchart because we love interpreting our own ways. We all are an expert, and we all love to put our own expert model. So what happens if we give a solution, a description to you as the owner of the business? You pass it on to your O&M manager. O&M manager will pass it on to your zonal manager, and then go to technician. By the time it will go to the technician, there will be a lot of interfaces to go through, and the solution that has been proposed, because of our interpretation, it gets lost. So we simply put that in simple flowchart, do it, check it, and make it simple. Our life, the way we are living at the moment, we love doing things complicated. If we don't do it well, we end up doing repowering, meaning you pay double to the project life cycle of the project. We're doing quite a lot of repowering work at the moment. A few examples from the UK. They are relatively old assets, about 7, 8 years old. And the reason actually there's a lot of repowering happening, not necessarily just because of underperformance, because these assets they have achieved their return. So they're trying to increase the asset value or asset life, and that's why they're doing a lot of repowering or revamping exercise at the moment. But when you say PV APM and those exercises that I mentioned, we're not going to say that you change module or change inverter, because that's not called optimization, that's called repowering. And that's where your operational capex get added up. If we do that, if scenario comes to that level, then of course you need to do a full cost benefit analysis. Any of those numbers that presented before in terms of uplift, none of the scenario that has happened. And another thing to mention, that we never actually worked with any project in that just under a gigawatt of asset where we've not achieved any uplift. The minimum uplift that we have achieved is 4%. A quick snapshot of the dashboard, but again, this is just a simple dashboard. Now, decision we need to make that we are looking for, or convinced with looking a fancy, sexy dashboard, or what is inside. I think this is quite important, that the factor that is inside driving this exercise for the benefit of the asset. And this is very much tailor-made. It can be customized to the KPI, key performance index of your contract, or your non-contractual KPIs that can be set it up together. Few case studies, a project from the UK, 20 megawatt project in southern part of the UK with uplift of 6%. Couple of projects in this one in Rajasthan. We did a couple of similar projects in Gujarat with 8% uplift. The highest one we have seen in Gujarat, couple of projects, 50 megawatt, 16%. Can you imagine that? 16% underperformance. It's a distressed asset. Another 10 megawatt project in West Bengal, a rooftop project in Switzerland. Now, this system can be adapted with whether it's a central inverter system or string inverter system or rooftop or ground mounted system, even for domestic application, but cost-wise it will not be attractive. This is an article, if you are interested, an article of mine was published in Energy Global Journal last year. And if you are interested, we have few copies in our stand at R620. Please do come by. We have some hard copies as well. And we are working with quite a lot of Indian players following opening our office last year in India. Most recent one of the public sector company, DVC, Damodar Valley Corporation, and Semcorp, Acme, India Power, OPG. So these are the companies that we are currently working with. And this is our overall footprint, not just PV APM, of 15 gigawatt in 16 countries. Thank you very much. And if you have any question, I'd be more than happy to answer now, or connect me via LinkedIn, or please do visit our booth.
Good afternoon, sir. Dr. Khushbu here. I just have a small query that after the plant is made, you are doing the analysis and assess management. What about the solar modules that have been already made with some of the defect? Do you also analyze like PVL, bankability data? Do you also use those kind of data, or is just after the plant is installed?
We do that. I mean, technical advisory, like I said, and thank you that you raised that question. Technical advisory, owners engineering, lenders engineering work that we do. And we do involve a lot of claim management at the end when we see a lot of underperformance. Now, yes, in terms of assessment of module, from thermal inspection, you do see some level of high-level assessment. So drone thermal inspection is not going to give you accurate power loss measurement of a string or of a module. And that's why you need to do electroilluminance EL test, which is for wider benefit. This is just an X-ray of a module. So yes, we do conduct that, and only time is needed is purely to work with a developer or IPPs on the claim management stage. Because it's always, we need to design what is the cost-effective testing scenarios of the plant and at what stage. So EL doesn't necessarily trigger at this stage when you do optimization, but when it goes to claim management, need proper evidence. That's when you need the EL test.
Also, do you see any opportunity of like Indian entrepreneurs to work in that field, like what PVEL or Sinovoltaics is doing right now to generate the bankability data or to set up this kind of facilities in India? I haven't seen much. Yes, UL and TUV is doing, but there are very small scale. So
only very few handful of different companies. So in terms of opportunity point of view, across the whole value chain, there are different opportunities, even for big players and for small players, because the size of the cake is too big. So even to get a small pie of it, still a big size for relatively medium or even small size companies. So yes, only very few names the big names that you mentioned, they are doing this, but there are a lot of opportunities. Now, what is the guideline and criteria for a new company to set up those facilities? There's a very clearly defined IEC standard how to do those tests, whether we do the test in the laboratory or we do the test in the field. I've seen those on-field tests deployed, not necessarily following those guidelines. The problem with that, if you don't follow those guidelines properly, the result outcome that will come out, they will be scrutinized at the bankability stage and will not be qualified. So better to do the job properly. Guidelines are given and technologies are available. Adaptation of those technologies with the proper guideline, with the proper mindset. I think this is where the main challenge is, that we do need to do things correctly. If we put things into under carpet, it will come up. So yes, definitely opportunities are there.
thank you.
Thank you.